Okay, so what I'm going to do on this video is do some more examples of finding the domain algebraically. It's not an easy topic, but with more practice, more doing them, that's why you need to keep trying them. Don't use technology, use your head. So again, what are the three things you want to think about? First of all, before I even say those three things, what are you finding when you're finding domain? What you can put in for x. So now we think of these three things. If we have a polynomial, we can put in anything. So the domain is automatically, without you even thinking, negative infinity to infinity. Second thing, we cannot square root negatives. So if I have a square root, if it can't be negative, it has to be greater than or equal to 0. So that's really where I say here, the top. The problem is I can have a rational function, number 3, where I have a fraction and I can't divide by 0. So the top of the function, we don't worry about unless it's a radical. The bottom of the function, if it's not a radical, we set it not equal to 0. If it is a radical, you're going to want to put it greater than 0 because it can't be 0 on the bottom. And you're talking about just what's under the radical. So don't do anything with the square root. So what I'm going to do is like 6 examples. So I look at this first example. So I'm like, okay, it's a fraction. What do I have to think of a fraction? With a fraction, the bottom cannot equal 0. But I have a radical on the bottom, which also means it has to be greater than or equal to 0. Well, if you put those two things together, it can't be negative and it can't equal 0. That means 3 minus 4x has to be greater than 0. So you solve that. Let's say I subtract 3, I divide by negative 4. That inequality sign is going to change. That's giving me what I can put in. I can put in x's less than 3/4. And I said yesterday, sometimes people like to see it visually on a number line. X's less than 3/4 mean you can put negative infinity all the way to 3/4 into that function and you won't get an error. If you put in 1 for x on the top and the bottom, your calculator would say error, but it's because of the bottom. So second one, we have a fraction again, but that fraction has a radical. Usually with a fraction, the top doesn't matter, but the top is a radical. So I know that has to be greater than 0. The bottom, since I have a fraction, cannot equal 0. So I got to solve that. So I got to do the top and the bottom. Well, if x minus 3 is greater than 0, x is greater than 3. Think of this quadratic, x plus 8, x minus 1. So your zeros are negative 8 and positive 1. That's telling you what it can't equal. So now, how do you get the domain? Put those three things together and realize that your domain is the union of all of those, the intersection of all of those. I'm sorry. So here's 3. I can put in x is bigger than 3. I can't put in 1, and I can't put in negative 8. Well, that really doesn't matter that I can't put in negative 8 and I can't put in 1, because I can't put in 1 anyway. Because 1 and negative 8 would give me problems on the top. So what's your intersection of that? 3 to infinity would be my domain. So if I go to the next one, sort of the same thing. I have a fraction. So what do I have to think of as a fraction? First thing, the bottom cannot equal 0. The top I usually don't worry about, but I have a radical. And I know any radical has to be greater than 0. I'm sorry, greater than or equal to 0. Actually, if I go back to this one, I don't know why I did that. It's greater than or equal to 0 because it's on the top. So I should have had greater than or equal to 3, which would have been that 3, and that would have been a bracket. It's only greater than 0 if the radical is in the denominator. So top is greater than or equal to 0. So 4 minus x greater than or equal to 0. Most of you guys will, so I know, subtract 4, divide by negative 1. X has to be less than or equal to 4. But now let's think about the bottom. This cannot equal 0. This cannot equal 0. Well, that means x cannot equal negative 1. This would be x squared cannot equal negative 1. That can't happen, because if you square root that, you get I. That's irrelevant. So now think of putting that together on a number line. First of all, for the top, it's got to be x is less than 4. But the bottom says it can't be negative 1. So at negative 1, it won't work. So now think of putting that together. If you think of really what that is, interval notation, left to right, anything will work up to negative 1. Negative 1 won't work. Anything will work after negative 1 up to 4. If you have an open circle on a number line, that's when you're going to do that, write it twice with parentheses. So now we got a little bit harder. We have a radical, but it's got a square. So again, you can see I'm just giving all these fraction ones. X plus 5, the bottom cannot equal 0. That's real easy. X cannot equal negative 5. I have my radical on the top, so that's greater than or equal to 0. Now this, if you think about this, we've solved this graphically last unit. But now if you think of really what's happening, add 9, square root, and when you square root, you get this plus or minus 3. Well, you actually have to think of absolute value. So x is greater than 3 are 4, 5, 6, and think of putting that in there. If I put 4 squared minus 9, it will work. But if I put 2 squared minus 9, I'd get a negative. So greater than or equal to 3 would be that. Well, when you square a positive, that's the same thing you get when you square its negative opposite. So what you get for 4, you get the same thing for negative 4. So greater than 3, you then want to think less than or equal to negative 3. Now we have to think of this thing, negative 5, it doesn't work. So really, what left to right, what can you put in? Anything to the left, up to negative 5. Negative 5 won't work, so I write it twice. Then it works until I get to 3. 3 works. I can have 0 on the top. Then nothing works. I'm sorry, negative 3. My negative was there. Then nothing works between negative 3 and 3, and then 3 works again to infinity. So definitely that's a harder question, but I can do that. So 2 more. Now I put the radical on the bottom. So this is actually easier. The top doesn't have a radical. Top can be anything. You can add 2 to any number that you want. The bottom, well, I know it can't equal 0, but I also have a radical. So when that radical is on the bottom, it just means you put greater than 0 instead of greater than or equal to 0 where you would on the top. So x squared minus 4 is greater than 0. Solve it, add 64, square root it, and you get x is greater than plus or minus 8. So again, think of that on a number line. That would be greater than 8, less than negative 8. The same thing you get for 9, you get the same thing for 9 as you do negative 9. So then put that domain together. What works? Anything from negative infinity to negative 8. Nothing works between negative 8 and 8. 8 won't work because it would give you 0, but anything after 8 will work forever. Last one. So what I did with the last one is I made it a little bit different. But it's very similar to the one we just did. The fact that the top is 3x squared minus 5x minus 7, who cares? As long as the top doesn't have a radical, you don't touch it. Any x could be put in on the top, but not on the bottom because I have a radical. If I have a radical on the bottom, greater than 0. So solve that. 100 minus x squared is greater than 0. Well, if you subtract 100, you got that. If you divide by negative 1, that sign switches, and you got 100. Square root, and you have less than or equal to plus or minus 10. Now, how does this change? Less than is a between. So what that means is less than 10 would be there, but then the same, what you get for 8, you're going to get the same thing for negative 8. So what that means is anything is going to work there between negative 10 and 10. So left to right, negative 10 to 10, that's your domain. So hopefully those examples help a little bit, but keep trying. If you just give up, you're not going to get it at all. Alrighty, we'll see you in a day or two.